My name is Zaira. My matrix number is CE2K51. I'm going to present the 1.1 part 1. So how the data acquired? Okay, we can design the simple transfer function and we'll get the data. Okay. The block diagram needed for this part 1, which we only need 3 block diagram. Okay, the first one is step, transfer function, and scope. So step function is to generate the signal. Scope is to display the signal. Okay, so each of these block diagram, we can change the parameters if we wanted. Okay, which I already changed the parameters of transfer function based on the questions. All right, so after we design this transfer function, we can run this program to see the output, which is I already did. So here is the output. All right, next is what is independent and dependent variable. So here we can see the transfer function equal to output over the input. So the numerator is the independent while the denominator is the dependent. So we know that from here, the dependent variable is MCK, which is those value of fixed. Okay, while for the independent, we have to see on the I mean, for the independent, we know that the characteristic such as the max overshoot or time rise and so on. So this value actually depends on the value of MCK. Thank you.
My name is Naomi Natasha Zairo, and I will explain about part 1.2 is what and how the analysis will conduct. So from the simulate I built from instruction, if we want to analyze the data, we need to run the simulate and press into the scope twice, and it will show the graph. This graph is the transfer function block diagram, where the waveform can see from the scope. From here, we can see the characteristic and transition that maximum overshoot rising time setting in all time, and all data we get from here. This tool is measurement tool, which means we also have the signal statistic where the mean max we will find the max, mean, medium, RMS. Also, we also can find the peak from here. If we set from measurement, from here we get all data that we can analyze to conduct the data.
Assalamualaikum and hi, my name is Muhammad Zari bin Zulkifli. So today I will continue question 1.3, and the question is what are the characteristic undamped natural frequency and the damping ratio. Firstly, let me get to this graph. The graph of undamped ratio is the green color and the damping ratio is equal to 0. This is the general equation of transfer function. The given transfer function in question is 1 over s square plus 2s plus 4. Because of the damping ratio is equal to 0, so the equation will become 1 over s square plus 4. And then the characteristic of undamped natural frequency is the waveform sustain the amplitude over the time. So if you look at to this graph, the amplitude will be same over the time. So let me prove in MATLAB, and we will get the graph like this. This is the given transfer function in question. So let me adjust the denominator. So this is the transfer function of undamp. So let's run. So this is the graph of undamp.
Okay, Assalamualaikum and hi, my name is Izzah Hazira binti Hizir and my metric number is CE190220. Regarding the question 1.4, build the required block diagram using Simulink. So this is the finished design of my plot diagram that I already built. I'm using a step, transfer function, and scope. For this transfer function, I use a value that already been given to us, which is 1 over s squared plus 2s plus 4. And the description for this response parameter is rise time. Time it takes for the response to rise from 10% to 90% of the steady state response. About the settling time, time is take for the error T equal YT minus Y final between the response YT and the steady state response Y final to fall below 2% of the peak value of ET. Settling minimum is a minimum value of YT once the response has risen. Settling max is about a maximum value of YT once the response has risen. Overshoot is percentage overshoot relative to Y final. And undershoot is about a percentage undershoot. And lastly, peak. Peak is peak absolute value of YT. So that's all from me. Thank you.
So from the part 2, the scope result pristine, which means we need to find the Simulink result. By follow the impedance variable will be given in instruction, we do the Simulink to get the result. By press the scope twice, we get to this graph, and this is our result.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zuhairi bin Zulkifli. So today I will continue part 2.2, System Transient Response Characteristic. Okay, based on the 2.1, the graph is referred to the undamp response. From the graph, we can find 4 value. Firstly, rise time. The rise time is time required for the waveform to go from 0.1 of the final value to 0.9 of the final value. And second, peak time. Peak time is time required to reach the first or maximum peak. And the third is percent overshoot. And this is the amount of waveform overshoot the steady state or final value at the peak time, expressed as a percentage of steady state value. And lastly, settling time, TS. This is the time required for transient damp oscillation to reach and stay within 2% of steady state value. Next, this is the pole plot of undamped second order. So this is how we sketch the pole plot for underdamped response, which contain real and imaginary.
Assalamualaikum and hi, my name is Izzah Hazira binti Hizir and my magic number is CE190220. So from the previous task from part A, that I need to build a block diagram, and for this part 2, I need to compare the result with the theories. So from this experiment, we have learned how to investigate the characteristic and the transient response, rise time, settling time, and the maximum overshoot. So firstly, we do the calculation for knowing the characteristic for damp, overdamp, critical damp, and underdamp. As we know, if the value of zeta is more than 1, it's overdamp. If the value is equal to 1, is critical damp, and if the value is lower than 1, it has been called underdamp. We also learned that there are two basic categories of control system, as we know as open loop system and closed loop system. We go to by part the characteristic of them, follow up by our block diagram. This and from this block diagram, the graph that we already get is this. This graph show us the underdamped graph. So the value of the graph is 0 is smaller than 1. So this is our graph. And for the calculation that I already calculate, so from this calculation, for the over them that I get is 2 is bigger than 1, and it is show us about over them graph. So for the critically damped that I already calculate, 0.1, 2.5 is bigger than 1. It can show us about critical damp. And for this underdamped that I calculate 0.03125 is bigger than 1 is underdamped, and it show us that from the theory and the calculation between the simulation that we already done, this being a successful because we got the same from the calculation that I already calculate. So that's all from me. Thank you.
My name is Zaira. My matrix number is CE2K51. I'm going to present 2.4 part 2. So by adding the new modified transfer function, we can actually get the best result, okay? So I change my transfer function, you can see that in the denominator, which is I change to x squared plus 8s plus 11. So after I run this program, I got this graph. So which we know this is for the critically damped graph, okay? So this is my second system, by the way. So we can actually compare the other characteristic. Okay, from here we can actually see for the second system, my rise time is 1.3 seconds for my and for my first system I got earlier is 8 to 1.45 millisecond. Okay, and we also can compare other characteristics, for example, overshoot and so on. Lastly, we know that for critically damp, we actually need to be our ratio, damping ratio need to be equal to 1. So from there we can actually prove our calculation is critically damped. Thank you.